Any challenges faced? Any topics made tough for you or made easy for you? You can share something. Or nothing happened? No impact?
Actually, these things need to revisit and practice from our side. Then the full concept will be clear.
Everything you have to do that way.
Yes, sir.
Definitely. So, what are the
Learning,
takeaways
so
yesterday?
we are just learning,
What,
sir, not yet implemented.
so there has to be some takeaway, no? Some effort. There has to be at least, some outcome. So, what did you learn yesterday? At least speak out, few of you.
Process capabilities, process performances.
Very good. Process
How?
capability. And you
Yeah.
understood capability is different, performance is different.
Yes.
Yes.
You also understood that it can be estimated. It
Yes.
cannot be calculated accurately, but it can only be estimated.
Yes.
With the best efforts, you get a better estimate.
Yes.
If you
DOE,
don't, yes, DOE. Another part is DOE.
factor analysis, and that R square adjusted and R square prediction, that variations and all.
Great. So DOE, design of experiments, and R square, adjusted R square, predicted R square. So where do we go for DOE? When there is a complexity, when there is a lot of complexity, we wanted to understand by conducting some experiment. So now we should not pray fall to the, experimental errors.
Yes.
If we don't take care, even after doing the experiment also, we'll take a wrong decision. So that shouldn't be the case. And purpose of DOE is not that. So you must now really, really respect, the requirement for the quality and quantum of data. If you don't have the desired level of, the required level of quality or the quantum, then your data will also mislead you.
Replication, blocking,
Yeah.
randomization.
These are principles of DOA. If people are misleading you and the situation and the data is also misleading you, then what will you do? You'll start making mistakes. So we have to be very careful about how to make our data worthy enough for the analysis, worthy enough for conclusion. For that, we always, we plan our experiments in a very, very effective manner. First of all, planning the experimental trials is very important. We learned something known as, design table, isn't it?
Yeah.
Based on the factors and based on the levels, we find out number of experiments needed to be run. Minimum number of experiments needed to be run, and definitely experiments have to be replicated at least twice, if possible thrice. And so you understand the grand total number of experiments. And we should also understood we need to randomize the trials. Why we should randomize? Very very sharp points there. We should randomize if you are
Minimize the
interested
errors.
in
Minimize the
minimize the error due to the noise factor. The effect of the noise factor can be minimized, and any other form of bias that may participate in your readings will also get avoided. That is why we must randomize. Why we replicate, I told you, and why we randomize, I told you. And blocking, sometimes you may have to block because you don't have time, because you don't have resources. There are constraints, so you have to block. And now the requirement is your blocks must be homogeneous. Otherwise, block will also appear as a factor,
Yeah.
and that will also be part of your regression equation, and that will create the scenario, make the scenario much more complex. Already seeing so many factors in our equation, means the process is complex. And you are now bringing another factor by name block. And what is this block? And that will block our thinking. So you have to make sure our blocking is, homogeneous, and all the trials inside each block are randomized.
Yeah.
So these are DOE principle. If you do all of this, and now you are doing something in the right direction, and now the data is generated, some statistics are calculated, and again steps are there. You have to calculate in a particular manner so that you can formulate the ANOVA table. An ANOVA table will comprise of so many so many values, and we can definitely some point of time we can teach you how each and everything can be calculated manually. But there has to be a necessity to learn that, and then only you will be able to understand. But whatever analysis you do, and you should immediately check for the p-value. Why we should check for the p-value? Can somebody tell me now? Why we are always saying, you check the p-value, check the p-value? Why?
Only then we'll be able to
Probability.
decide which hypothesis, whether we have to reject the null or fail to reject the null. Only then we'll be able to decide.
Whether we have to reject the null or we fail to reject the null. That's why that's a decision-making procedure. But what is this p-value is actually telling you? What are your
The-
understanding? If
The
somebody
effect
asks
of
you in the
random
interview,
chance.
It
The effect of
says,
random chance.
if there is
We
a
would have-
random chance of seeing your statistics similar to what you observed in the experimental result, right? Then what is the meaning of the experiment? If it happened randomly, does it mean the experiment is communicating something?
Maybe there would be two kinds of observations, one based on statistical data and other based on more common causes observations. In order to decide which to go with, we need to decide the p-value.
Okay, anyway, good that you brought one more term, common cause and special cause. The common cause is otherwise known as random cause.
also
Whatever
the
you observed
p-value.
in the
Sorry.
yes, please go ahead.
Also, the p-value tells us like whether we are on a safer side, the right side, variation, whatever, or the left hand side.
Whether the variations are due to common cause or special cause, that is the question p-value answers.
Okay.
If it is due to a common cause or a random cause, how can you assign this variation to the, how can you attribute this variation to the factor? But
Sorry, sir, can you
random
please
cause,
repeat the question?
but random cause cannot be eliminated completely. In every experiment, there will be some
Some
variation.
level of.
Random variation cannot be eliminated completely, even though you control all the entire environment to the extent possible. Then also there is a chance for a random variation. Hope all of you agree.
Yes.
What percentage of random variation you would like to leave? That is the
5%.
question. 5% normally no. The experimenter will always assume that or okay with leaving 5% chance for the random variation. All right. So if our statistics has to have an effect, at least more than 5%. Do you understand? If our statistics should have an effect, at least more than 5%, it has to enter the significance area. I mean, it has to cross the confidence limit. It has to cross the line of significance. The wherever you draw your 95% confidence limit, that is known as line of significance. So if your statistics crosses that, then it is for sure your
Experiment.
statistics has crossed it because of the factor you are studying. Because the moment you see your statistics crossing the line of significance, it is now clearly evident that the random cause has only less than 5% chance. The random cause has only less than 5% chance. So that's the reason why whenever the p-value is going below 0.05, we reject the null and then proceed. There is only 5% risk we are running. In other words, p-value is the risk of committing a type 1 error when it happened to reject the null. When it happened to reject the null, p-value gives an estimate of type 1 error that may happen. You are rejecting. Still, there is a chance for your decision of rejecting the null may go wrong. For that, how much chance is there? The p-value will tell. And the rule of the game is it should be below 5%. That is why only when p-value is less than 0.05, we reject the null, isn't it? Whether the experimental findings are okay to believe or not. Whether the experimental findings are okay to believe or not. They are okay to believe if p-value is less than 0.05. They are not okay to believe as per the rule. As per the rule decided by us. Before experiment, we decided alpha 5%. That means we check, right? And over and above, we learned one more important thing yesterday, that we must apply our common sense before proceeding. Even though p-value is less than 0.05, your common sense should also necessarily support your decision. Am I correct? All of you
Yes.
understand this?
Yes.
Agree with this?
Yes, sir.
Very, very important. All right. So we discussed about DOE. I think you all have become knowledgeable and skillful in conducting designed experiments. And we also talked about CPCPK, PPPPK. One is capability, other one is performance, and both are estimations. So it depends on the data quality. So give importance to data collection plan, give importance to the accuracy of the data. Otherwise, all your estimations, will become inaccurate, and hence your decisions may not be appropriate. So you have to be careful. And then we moved on to, I think Vivek sir taught you something, isn't it? Pooh matrix.
Yes.
And then
Yes.
he explained you,
Six
what is the other
tracking
one?
hacks.
6
Six
thinking.
thinking
And then
hacks.
they are fundamentally types of brainstorming, ways of brainstorming, isn't it? You are making people to think in the required manner. See, when you are talking to someone, the other person should also think with the same frequency, isn't it?
Yes.
Yes.
Otherwise, his thinking may not be helpful for you. So we are actually, setting the stage, setting the environment, and tuning the frequency. We are harmonizing the place to discuss a specific problem and come out with some kind of ideas. The idea can be an idea about the solution, or idea can be the, ideas about the root cause, whatever it is, right? Whatever is the subject, yes, you can do it. Ultimately, why we brainstorm? We wanted to come to a common agreement. If you alone can take the decision, but then what happen? Even though the decision is one of the best decision, with the people's poor cooperation, you will not be able to implement. So whatever, even though you did a lot of exercise, lot of research, and coming out with a lot of findings, make your people understand what you did and try to involve them, right? Make them feel the privilege of, being a part of your project. Then what happens? You will be able to gain their support. This is very important to effect any changes. Otherwise, management will become a big challenge for you. You have done a good job, great job, but it ended up, with a poor implementation. So it shouldn't be the case. So that's why we bring some kind of soft tools here and there, brainstorming, critical thinking, and all those stuff. 6R thinking, nominal group technique, or any
FMEA.
other technique any other technique that and empower everyone, and make everyone feel, part of your success. Then only, you will be able to affect the changes. Anyway, you as a project leader, you will definitely, deserve your results. All right. So and FMEA also you spoke, am I right?
Yes.
You learned FMEA. So FMEA, see, we have been talking about defects. We have been talking about waste. Of course, coming Wednesday, we are going to have one session where we will focus on some tools exclusively, designed for eliminating the waste. We are having that session, will be an additional session we'll be having on Wednesday. But there is one more thing equally important, not only defects, not only waste. There is a risk. Risk should also be quantified, right? Even after, whether reactively or proactively eliminating the defects and waste, still some possibility for a failure will exist. All of you agree?
Yes.
So how much possibility exists? That is known as risk. You have corrected some failures. You have prevented some failures. Still, beyond your capacity, beyond your knowledge, still there could be some more opportunities for a failure, remain unattended. That is known as risk. That risk should also be measured. There are different ways, and one such way is FMEA, where we go with the metric known as RPN, risk priority number. It is measured using 3 metrics. One is severity ranking, another one is occurrence ranking, another one is detection ranking. And now, in order to do the FMEA exercise, it is again a teamwork.
Okay.
There has to be a group work, FMEA team, and can be a cross-functional team. And you should be able to think from the customer standpoint. You should be able to think from the customer standpoint. Then you will be able to give the ranking properly. If you think from your standpoint, and you may give irrelevant ranking and finally end up calculating, an RPN, which may not actually, reflect
Cost
the
and
risk
impact.
involved. Yeah. So there are different ways failure can happen. Right now, our training program, right now going on, there are different failure modes possible. Suppose poor internet connectivity can be a failure mode, isn't it?
Yes.
We may be delivering a good stuff, but then the internet connectivity is poor. So everything is breaking and then, you are not able to receive. Now, what do you think your customer experience will be if the network failure, happens very frequently?
It would be poor.
And what do you think? What do you think in terms of severity? Would you okay to adjust,
No.
or would you expect the session to be, uh, conducted
Smooth.
again?
We will
would
come
I
up
want-
with
expect the
some.
session to be conducted again.
We will
Session
come
has
up
to
with
be.
some backup plans.
Yeah, backup plan is the solution. Right now, let's say we are experiencing the internet connectivity issue, right? The trainer is not being able to, I mean, he is speaking, but you are not able to hear, and he is not able to share the screen. There are a lot of complications. And what do you think the severity will be if this kind of problem happens in an online training program? From the customer viewpoint, is it a high severe problem or a less severe problem?
High severe problem.
High severe. So how much score you should give?
8 to 10.
Almost full.
So you should think from the customer standpoint. If there is a spelling mistake in my slide, that is also a failure. But now your customers can tolerate to certain extent, isn't it?
Yes.
It's a spelling mistake, and definitely they feel bad seeing a spelling mistake on the slide. But it's a failure. But what is the severity? What is the impact it
Less.
creates?
Very less.
It is very less.
One or two.
Now you can give one.
Yes.
All right. But severity for same problem, maybe in a different scenario, a problem with the severity ranking of 1, maybe in another industry may become a severity ranking of 10.
Yes.
Right? Let's say a small spelling mistake in the title of the book.
High severe.
Repetition. Repetition.
Now it is a high severe problem. You are a publishing company and you publish the author name with the spelling mistake. And now this becomes a high severe problem. So you must understand only when you look at the problem from the customer's perspective, then only you will be able to rank it properly, not from your perspective. Who is going to feel the pain in that way? So, but the guidelines might say if something hazardous, something happens suddenly, you give 10. And putting your title with the spelling mistake is also equally hazardous. It is going to damage your reputation, isn't it? So that's how the severity ranking, occurrence ranking, and detection ranking have to be assigned. And then the RPN has to be calculated. The industry's practice is less than 100 is preferred. Slight up and down, normally companies do that. Some company says 120, we go up to 120, we are okay with 120. Some company might even say we are okay only up to 80. Normal practice is 100, right? And over and above the RPN method, there is another method you might have studied yesterday, action priority. For every combination of severity, occurrence, and detection ranking, there is an action priority available, indicating as low, medium, and high. Finally, whenever you get an action priority of high, you must work on the problem on top priority. So FMEA is a tool to prioritize your problem based on the failure modes and the risk associated. So risk is also getting quantified, right? So traveling in a car and traveling in a bike, which is more riskier?
Bike.
If you have to travel for 100 kilometers in a highway, which
Bike.
comes with more risk, bike or car?
Bike.
Bike. And traveling with 40 kilometers more riskier, or traveling with 80 kilometers more riskier, or traveling with 120 kilometers more riskier?
120.
Yeah, if you allow the risk to increase, and eventually the failure will happen. So that's why, in FMEA, we think of controlling the risk. So I think this is what we have learned yesterday, right? As a summary. And now we are going to proceed with today's topic. And the topics are Kano model and QFD. Very, very simple tools. Kano model, QFD, and maybe if time permits, I also would like to show you the graphs that is getting generated after conduct of the gauge RTR, right? So these 3 things I will try.